Hello, I'm Steve Williams, and I work for RT Logic, an AGI business partner. Thanks for joining us for this short video. You already know that STK is an exceptionally powerful tool for physics-accurate radio frequency signal monitoring and simulation in dynamic environments, calculating the impacts from flight, weather, terrain, antenna characteristics, and many, many other factors. At some point during development and testing processes, many STK users have a need to move from pure software simulation into full, physics-precise, hardware-in-the-loop testing as they seek to answer the vital question, how will my RF hardware, firmware, and software actually behave under these mission conditions? At RT Logic, along with AGI, we've developed a way to answer this question. The RT Logic T400CS channel simulator bridges the gap between pure software simulation and live testing or operations by providing hardware-in-the-loop RF signal emulation. Think of the channel simulator as a hardware extension to STK, letting users apply STK scenarios to actual hardware, firmware, and software all in real time. Imagine an STK scenario where you're analyzing, testing, integrating, or developing equipment for the scenario shown here. An unmanned aerial vehicle passing data through a satellite to a mobile ground location. When you need to actually test the radios, modems, and other equipment that will be used in this scenario, you can do this in a few ways. First, you could set up a live test to fly an aircraft, position a mobile ground station, and transmit signals through satellites. Unfortunately, live tests can be very expensive, even dangerous. You may have to wait for worst-case signal impacting weather conditions, and the test may require resources that are simply not yet available during early test stages. A second option is that you could connect the transmit and receive equipment together directly with a cable. This verifies that the equipment can communicate, of course, but the test ignores anything and everything that impacts signals during satellite uplink and downlink. Your third and best choice is to connect the channel simulator under STK control between the transmitter and the receiver. The STK and channel simulator combination can add the precise signal distortions being modeled in the STK scenario. Things like dynamic attenuation, Doppler shift, and time delay, because the channel simulator can also add atmospheric noise, interference, and jammers, along with the effects of antenna beam shapes, terrain, weather, and multipath. The receive equipment now sees signals identical to those transmitted from the UAS and passed through the satellite down to the ground location. RT Logic has created a plugin for STK that collects detailed RF link behavior information directly from the STK physics engine. As the scenario plays, the plugin automatically sends commands to the RF channel simulator, creating a real-time RF signal environment that precisely matches the running scenario. Here's an example of the system in action. We're transmitting digital video through one modem and having that same signal being received by the second modem. The channel simulator is electrically connected between the two modems. This demonstration gives a visual indication of how signal propagation effects impact the quality of the received video. Now, let's take a look at some of the individual contributors to overall signal distortion utilizing our embedded spectrum analyzer. The channel simulator can add effects for Doppler shift to emulate frequency and data rate changes due to relative motion, time delay to emulate the signal propagation time, attenuation to emulate path loss, weather fading, and antenna patterns, multipath fading for urban, water, or close terrain effects, additive white Gaussian noise to simulate atmospheric noise, interference to emulate accidental or intentional jamming from other signal sources, programmable filtering to emulate the phase and magnitude response of equipment in the RF path, such as satellite transponders, and finally phase noise to emulate jitter from equipment in the RF path. RT Logic created an STK plugin so teams could leverage their extensive modeling and simulation investments directly into hardware-in-the-loop simulation. As a scenario plays in STK, the plugin captures simulation data directly from the STK physics engine, commanding the channel simulator to create real-time RF signal environments that precisely match the running scenario. The STK plugin works with any pre-existing scenario. The channel simulator can emulate almost any RF channel, whether these are part of SATCOM scenarios, aircraft missions, rocket launches, ground communications, or test range applications. If you can create the scenario in STK, the channel simulator can create those impacts in the RF signal. The system is available in several form factors and with key specifications customized to each user's individual requirements. Bandwidths up to 250 megahertz are available, along with a wide range of frequency coverage from VHF through Ka band. The instrument includes a simple GUI interface, a remote programming interface, and a text-based format for creating your own dynamic simulation files. When STK users need an easy and integrated method to test their RF communication hardware, firmware, or software, connecting STK to an RT Logic channel simulator is the logical next step. The user's investment in building detailed STK scenarios pays off again, as those very same scenarios can now control hardware-in-the-loop testing. This saves scarce program funds, improves safety, and increases the depth and repeatability of critical testing. For a demonstration or to request more information, please contact AGI or RT Logic.